Hello viewers, welcome to the session on Hierarchical Approach in Clustering Technique. Please make sure to watch all the prerequisite videos for your clear understanding and to make best use of it. So this is third topic under Major Clustering Technique. So in Hierarchical Clustering algorithm, work is done by grouping data objects into tree of clusters. This method does not require the number of clusters k as an input, but it needs a termination condition. In general, there are two types in hierarchical clustering, and these are agglomerative hierarchical clustering. It is a bottom-up approach, and it starts by taking each object as one cluster, and it then merges them into large clusters until all objects are in same cluster or some termination condition is met. On the contrary, divisive hierarchical clustering is a top-down approach, and it starts by putting all objects into one cluster and then goes on subdividing them into smaller clusters until each object is in some cluster or some termination condition is met. So let's look at the diagrammatic representation of agglomerative and divisive hierarchical clustering. In agglomerative clustering, what we do is we start from individual objects and go on merging them into one cluster according to the similarity, and then we do and continue this continuously until some particular condition is met or we get the complete whole objects into one cluster. Similarly, divisive is just opposite of agglomerative. It starts from whole one clustering and goes on splitting it into subclusters until we get all the objects into separate clusters. And the tree structure is represented using a data structure called dendrogram. So agglomerative and divisive can be represented through a tree structure called as dendrogram, which is as shown below. One of the main methods in hierarchical clustering is BIRCH, which stands for Balanced Iterative Reducing and Clustering Using Hierarchies. It's a hierarchical clustering method and introduces two concepts. First is clustering feature CF and clustering feature tree, which is CF tree. Now in clustering feature, if C is a cluster with objects O1, O2, O3 up to On, then CF is defined as a triple of n, ls, ss, where n stands for number of data objects, ls stands for linear sum of the objects, and ss stands for sum of squares of the objects. Let's take an example to understand it in much clear way. Let us suppose C is a cluster of 3 ordered pair, that is 2, 5, 3, 2 and 4, 3. So the number of data objects here are 3. Similarly, the linear sum of the object is 2 plus 3 plus 4 and 5 plus 2 plus 3, which comes out to be 9, 10. Similarly, the sum of squares of the object has been calculated and it comes out to be 29 and 38. Then the clustering feature is defined as CF is equal to 3, 9, 10, 29, 38. A clustering feature tree is a height balanced tree that stores the clustering features for a hierarchical clustering as shown in this picture. Here the point we need to keep in mind is that the clustering cannot be very few and it cannot be a number which can be out of the box. So we have to maintain a balance between the number of clusters, and it is well taken care of by the clustering feature tree. And we have two parameters in clustering feature tree, which are branching factor, also called as B, and it specifies the maximum number of children per non-leaf node, that is for internal nodes how many children are there. Similarly, threshold T, which specifies the maximum diameter of the subclusters which are stored at the leaf nodes of the tree. So let's now discuss the primary phases of BIRCH algorithm. In the phase 1, BIRCH algorithm scans the database to build the initial CF tree, and once CF tree is built, then it applies a selected clustering algorithm like partitioning algorithm to cluster the leaf nodes of the CF tree. So now let's look at the difficulties with hierarchical clustering. The selection of merge or split points is critical because once the objects are merged or split, Next operation will be on the newly generated cluster. It will neither undo what was previously done nor perform object swapping between the clusters. If merge or split points are not chosen well, then the quality of the cluster gets affected. And moreover, selection of these points needs evaluation of good number of objects in the cluster. I hope this video proved fruitful to you and hope you have gained something extra than what you were knowing earlier. Thank you.